Okay, then we have making compatible numbers. So let me give us something to add together. So 9.27 and 3 plus 7, 9. Okay, so with making compatible numbers, I'm going to think about what can I split this up into that would be nice and pretty to kind of see in my head. And I see, it's like I got $9.27 and $3.79. Well, if I had 25 cents and 75 cents, that's nice and pretty because 25 plus 75 is $1. So I'm going to split this up, 9.25 plus 0.02 and 3.75 plus 0.04. I'm going to split those guys up, then add them independent. Like I said, 0.25 and 0.75 is $1. So 9.25 plus 3.75 is 13 even, and the 0.02 plus the 0.04 is 0.06. And so I can very quickly see that it's 13.06. Again, making compatible numbers, taking what I've got, breaking it up into easier things to work with, and then adding up the easy things, and the leftover stuff just gets added up at the end. Balancing with subtraction. Okay, so let me come back here, give us something. So 4.63 minus 1.97. Okay, so with this, I want to think about, with subtraction, it's really nice if it was 4.63 minus 2, that would be really easy to do in my head, right? 4.63 minus 2 is just 2.63. So then I want to think about, well, how do I get that bottom number up to 2? How do I get it up to 2? If I add 1.97, so if I add a 0.03 to it, let me kind of write this out. So if I add a 0.03 to that number, then I get that to say 2, but I can't just add that willy-nilly. Whatever I add to one, I got to add to the other. So I'm going to add 0.03 to the top, which is going to change the top number into 4.66. But in the, sorry, I didn't mean to draw a fraction bar there. But in the bottom, I have just a whole number 2. And so we're right back to that. It's really easy to do in your head. So 4.66 minus 2 is 2.66. That's not that bad. Okay, and last thing we're going to look at is balancing with decimals with division. Okay, so with this, I'm going to ask myself, it says 0.25. Man, I wish it said 1. Because if I divide it by 1, that's a really easy problem to do. Well, is there a way I can get 0.25 to say 1? Is there something I can multiply by to get that to happen? Yeah. If I multiply that by 4, 4 times 0.25 happens to be 1, right? But what I do to one side, I got to do to the other. So 8 times 4 is 32. And now my problem is 1 divided into 32, which is clearly 32, right? Nice, easy technique, something we can think about. Okay, so the last estimation technique, last mental technique we'll talk about is estimating, and then we'll address this idea of round-off errors. So let me give us some numbers to add together. So 2.39, 0.89, 6.13, 4.75, and 5.05. Okay. And so I want to estimate the sum of this. So looking at the numbers then, I'm going to just do a quick change a row on that. 2.39 is close to 2. 1.89 is almost up to 1. 6.13 is almost 6. 4.75 is almost 5. And 5.05 is a little bit more than 5. Okay. So I'm going to change those numbers to whole numbers, and then the whole numbers I can add a little bit quicker than have to deal with all those decimal places. Again, this is a quick estimation technique. So 5 and 5 is 10, 16, 17, 19. Okay, so I'd estimate that would be kind of close to 19. Let's do one more of these. So 72.8 minus 17.5 is what I really want. However, 72 is really close to 70, and 17 is really close to 20. And so I would estimate that my answer would be somewhere in the vicinity of 50. Okay. Okay, so now that we have these two estimations, we want to be aware that how accurately can we trust our answer, okay? And it goes back to how bad did I round? Well, in this first example, right here with the 19, I rounded one, I took 3 digits of accuracy and rounded it to 1 digit, okay? So that means my answer really about the only thing I can put any value on is that 1. So I can say my estimate is 19, but honestly, the answer could be anywhere between 10 and 20. That's about as close that I can promise because I was only 1 digit of accuracy when I estimated. Okay. Same thing over here. I took a 4 digits and I rounded it to a single digit of accuracy. It's about the only thing I can say has any value is that 5. So I know it's around 50, but I can't say 51 or 52. I can only say that the answer's got to be around the 50 mark, just based on how much I estimated. If I instead rounded it to, let's take that same problem, 72.80 and 17.5. If I instead rounded it to 73 minus 18, right? I'm still an estimated answer, but now that second digit has a little more value because I took it into account. I rounded to the second digit. So let's see, what is that? Carry the 1. So we get a 5. So 55. Okay. So now, because I have two digits of accuracy, I rounded up to the second digit. Now I know that the number is a little bit closer to 55. So I have a tighter estimate. But anyway, so you just want to be aware that when you, the moral of the story is when you round, you tend to be off in your answer. And how much off depends on how much rounding you did.